So guys, let's see about this one. Okay, I told you I was going to do a distributed load problem regarding beams. So let's just go jump into that. So since you already know the whole deal, but if you don't, so let's just recap. Okay, so I'm gonna do equilibrium 2D for this one. Okay, so this is the body that I have over here. Okay, this is the beam. I have an AY going there. I have an AX that way. This thing over here is NC due to the roller. Now I have a distributed load, but we already know how to deal with distributed load. So the thing is that I can say that overall that length is just, I just have 1 point force acting right in the middle of the beam. So let's see how much that is that thing. So it should be 120, that is the height. It's like the intensity. It's actually a force per, not times, but per unit of length, okay, that you have here. So every feet that you step into the beam, you will add 120 pounds, okay, 120 pounds. Therefore, this guy is right located here at 6 because everything is 12. So right in the middle is located this 120 times 12. So times 12. So that this is the resulting force of this distributed load plus this 900 over there. Okay, so according to data, it's 4 meters, 4 feet, sorry, from this corner C. Okay, so you have point C, you have point B over there, and you have point A. Got it. So this is actually pretty simple. Let's just try and do it. So for X, you will have AX equals to 0. I think I was wrong in some other video that I put 0 equals to 0. That's not actually true. This is actually AX equals to 0. Nobody is doing something laterally, so this AX shouldn't be compensating anything. So that's why it's a 0. Now let's go with Y. For Y, you will have this AY. Okay, let's just put the AY plus the NC and minus, let's just put it this thing, but over here as positive. This should be, okay, 1.4, okay? This is the product of this. Okay, 1,440, okay, minus, I mean plus, because I put it the other way like that, okay? So horrible numbers. I thought this was going to be easier numerically, but okay, it is what it is, and let's not complain about it. So if I do my math right, it should be 2, 3, and 40, okay? If I'm wrong, you tell me in the comment section. Now that's what I have. Therefore, moment regarding, let's say, A equals to 0. If I put that, I will have that, let's start with this 140. So let's start with this one over there. So this is the force, which is actually acting here, okay? So it's a distance of 6, okay? So regarding A, it's 6 feet out of that, out of this corner. Therefore, this thing should be negative. Got it. Now, what about this other guy? This other guy is how much? Now, I need to walk 8 to get the 900. So 900 times 8, okay. And this is also, oh my God, also a negative, plus NC. Now NC, it's going the other way around, times 12. Okay, equals to 0. Now with this information, I can get that I have NC, can I get rid of this? I don't know, I will try that later. So NC equals to something. Now let me just try to do my thing. So let's just put here, I divide everything by 2, okay? So 6, therefore you're 4, therefore you're 3. Let me see if I can do something else here. Let's just divide everything by 3. Yeah, I think I can do that. So everything by 3, therefore you're 2, okay? Therefore you're 300, fine, and therefore you're 1, okay? I think that's more comprehensive for me, and I think I can do it again, okay? So this is a 1, okay? Therefore this 150, I'm gonna put it over here. This is a 150, and this thing, instead of 144, it should be a 720, 7 and 20, okay? Because I just divide everything by 2. Okay, so I'm gonna make myself some room over there. Remember, I don't use calculator, I use my brain, and that doesn't mean anything, okay? That just does, that just means that I don't, most of the times I will be wrong doing the numerical calculation. But again, what I try to do here is to let you know how to solve this stuff instead of getting the numerical result right. Well, okay, I think that's a pity excuse, but it is what it is. So NC should be equal, perhaps I'm wrong, you will tell me, plus 720, okay? And this is a 600 plus 600, right? Because 150 times 4, it's a 600. Therefore, I will get with a 13, okay, 20. Fine. Now for AY, this thing equals to a 2340 minus 1320. Therefore, oh my God, I'm dealing with arithmetics right here. So what I'm doing over here is this is a 1020. I think that's right. Okay, so I think, let me just check it once more. I'm trying to add these two guys and I will get a 40. I think I'm right. So yeah, so these are pounds and these are pounds. Now you get the information. Well, okay, let's see what happens next. This is the first time that I'm doing it and I don't have it on paper here on my notes. Therefore, I'm just making this thing as I go, which is good, okay? Because you challenge yourself somehow. Let's start with the creepy part of this. Now, I need to erase this so I don't confuse you a little bit more. Therefore, let me just put this one, the marker. Okay, how many sections would you do here? Let's see, this is a new guy. The new guy is the distributed load. If you had just point forces, you will say, okay, so one and before this point force of 900, right? That would be the case. But do we have something else, some new entity, okay? This distributed load over here, how can we deal? Like, what's the criteria of putting sections here? Well, what I can tell you is this thing. The criteria, I'm not going to write this, okay? I'm gonna just tell you this. The criteria is if the distributed load doesn't change the slope, you know, this slope over here, if that thing doesn't change, so you only need to put one. That's a criteria for distributed loads. Okay, now I'm gonna put one example over here. So if you have this stuff over there, okay, this is your beam, and up here you have this distributed load. So you have this, the criteria that I just told you says that you need to put just one section, okay, with just one section regarding this slope over here. So how many slopes do you see here? Well, I just see one slope, fine. So just put one section. This is what you have over there. And this section will go from this corner to this other corner. Simple as that. Okay, so nothing. That's the criteria. For one slope, for one type of slope, for one value of slope, you need to put one section. What will happen if you put this? So maybe you have this, and the distributed load just ended there. What happens? Well, the criteria says, okay, if the slope doesn't change, just put one, okay? But after this, something has changed. This beam doesn't have this distributed load, so you need to put another one, okay, to study what's happening inside it, right? So you will say, you can say that it changed the slope, okay? So this distributed load was with a slope of, I don't know, in this case, we have 120. This is like our slope, 120 pounds per feet, fine. And 120, 120, 120, 120, and then zero. Okay, so it changed slope. You need to put another section. Hey, what about this? Okay, so let's just put another example. If you have this beam over here, and you have this like that. Well, I think maybe you have the idea of what will happen over here, but I will put a section here just because of this slope, or the value of the height, if you want to put it like that, and another one here, right? So you just have two sections there. Now let's see another one. We will see that these guys later. I will put an example about this. Well, now this is a triangle distributed load. What would you do? Okay, so again, the question, how many slopes do you see? Well, I just see one value of the slope. It's something that is going up, right? So it's changing. Well, but the slope is actually not changing. It's just this slope, right? So you have this same slope over there as if it was a straight line and it had just one positive slope, the value of the slope, right? Well, okay, so just put one. But should I put another one? Why would you put another one? If you put another one, what changed over there? Nothing has changed. But you will say, well, the height, okay, fine. I don't care about the height, I care about the slope. Okay. So that's the idea of putting sections when you're dealing with distributed loads. So hopefully it's not that difficult to see how many sections I'm gonna do here. So let me just erase all the stuff that I have put over here. Okay, it's not a bad idea to know that. We will do exercises like that. We just put beams and let's see how many sections. Oh my God, one more. So let's just erase this. And now let's just put some, now let's just be more dramatic. Let's just put like that. Okay, so you have all this guy, you have one distributed load with one constant slope, right? Well, okay, so I'm gonna put one. Oh, but I have this guy over here, and this guy is telling me you should put one before and after. Fine, so that's what I will put. Okay, so what did the distributed load what was the contribution of this distributed load for the section part? I will tell you, well, maybe you say nothing, or I would say everything. That is that you have one slope over here, put a section. Okay. Oh, then it comes a disturbance, which is this point force over here. Well, okay, just put one before that one. Oh, I already put that one because of the the distributed load. Fine, let's just leave this one over here. This guy is gonna be our first section. Hey, what about this other one? Well, I just followed the rule. The rule was after one disturbance, before and after a disturbance, you need to put another section. Well, this is my section 2. So with these two sections, I can analyze what is happening in this beam within regarding, remember, shear force and bending moment, okay? So let's just hit it. So 1, I don't know why it moves. It moves like maybe I don't know, I'm putting some buttons over there. Well, okay, so this is what we have over here, and let's just see about it. Yeah, I don't know what it's moving. It has this cursor over there, and then it will change. I don't know, it does what it does. So section 1, okay, so I'm gonna put this chunk of the beam over there. This guy, I already know it. There is this guy over there. What is that? Well, buddy, that's its distributed load. Oh, but not the whole deal? No, just a chunk of it. Why? Well, because it goes from this point to this point. This is where the section 1 is sweeping from A to B. Oh, okay. So this is point A. This is not point B. This is point O, where you broke the beam and the distributed load. You will see the shear force. You will see the bending moment. And what else? Well, nothing else. Okay, fine. So what should I put over here? Well, what you should put over here is your X, because that thing is missing. And you need to remember that this guy was 120. This height was 120 pounds divided by feet, okay? Okay, but I already solved it, you know, I already put this. Okay, so this guy is not going to help you in this section part. Why not? Because you did this calculation for the whole freaking beam, for 12 feet of beam, and you don't have 12 feet of beam over here. You have X feet of beam. Oh, so this is a little bit more troublesome. Yeah, it's a little bit more troublesome. Well, but let's just go. Let's see what about Y, because the X part, you know, it's trivial. So let's go about a Y. So for Y, I will have this guy that I didn't put its value. Its value is 1020. Okay, so this AY is, we already have it over here. Remember that one. So it's going up, and you have continuous load going down. Fine. So what I will put for this, it's a 120 going up. Oh, let me just put it here. So 120, 1020 going up, and then what going down? Well, you will have this. Hopefully it's not that difficult. Minus 120 times the base, and the base is X. Okay, as simple as that. Really simple. Yeah, you get this. This is actually the truth. So you have a base of X, that is the length of this chunk of the beam, its length is x, okay? And over here you have 120 going down, okay? So every time you step, every feet you step into this beam, you need to add 120. Well, okay. So if you step into this beam x steps or x feet, well, you need to add them up going down, right? So it's simple as that. It's the same rule, but not with numbers, just with a letter. That's algebra. Well, now minus b, and this thing is equals to 0. So you will have that b equals to 120. This guy doesn't move, so it's still the same, 120x. When you go from x equals to 0 till you go to x equals to 8. Okay, so you move around all over here, and maybe you see it, but this is your limit over here. All this thing is your limit. Okay, now you need to calculate it. Okay, so when this thing is 0, you have the 1020, okay, pounds. And when you are calculating it at 8, you will find yourself with what? Well, you will have, well, 1020 minus this thing, which is 960, if I'm not wrong. So yeah, I'm not wrong. Therefore, you will have how much? You got this number over here. Oh, I'm still dealing with this. So this guy should be 60. If I'm not wrong, this thing should be 60. Therefore, this is what you have over there. This is a straight line with a negative slope. Okay, so you start here at 120 and you will end up here at 60. Okay, so let me just put it. This thing is not a scale. It's not intended to be a scale, okay? But this is what you have over there, okay? 60. So hopefully I'm right with this numerical calculations, and there you go. This is the shear force that this beam is feeling from A to B, okay? Then it will come the 900, and we will see what happens later. But right now we won't care about it. So M, regarding O, what are you doing right now? Well, what I'm trying to do right now is to get the bending moment. So I will put the bending moment as positive, then the 1020 times x, and this thing should be a minus, times the times this distributed load going down. How the hell can I get it? Well, hopefully you don't see this too strange, okay? You already got the resulting force going down. This is this guy, okay? So you need to compute anything all over again. So this is your force. You still need to get the distance, but so far, this is the force, okay? You already got the force over here. This is a force equation at y, okay? So this is a force equation. So this is actually the force. Now you need to multiply by a distance. Well, where do you think this 120 times x is gonna be located? Well, no surprise, it's gonna be located right at the middle of this x of unique length, this beam that measures x, that has a length of x as a base. Well, buddy, I don't know you, but maybe you see that this is like that. I don't know the value of x, but I know that the resulting of this chunk of distributed load needs to be located right in the middle. Why? Well, because it's a rectangular distributed load. Well, okay, so x divided by 2. Oh, but no numbers. No numbers. So this is the distance. Let me just put it like that, okay? Force times distance. This is what you want over a moment, right? So this thing should be equal to 0. Hey, let me just deal about the sign. This guy should be a plus. Well, okay, now let's just do our stuff over here. Okay, again, when you go from x equals to 0 till x equals to 8, and now let's just, well, I think I have enough space, so this thing will be 1020x, okay, positive because it passes the other way around, minus, and this thing, this 2 with this 120 gives me a 60, therefore I have a minus 60x squared, okay? Now, let's just compute this when this thing is 0, fine, so therefore this thing will give me 0, which is a good It's a good way to start because it should start at equilibrium. Okay, so 0, fine. And when this thing is 8, let's just compute it. Okay, if this thing is x, you have a 1020 times 8. Okay, so let's see how can I deal with that. Minus 60 times 64. Okay, so I got the easy ones, right? I'm just joking because this is a real hard thing to do for me, at least so far. Okay, so what you will have over here is the okay, so it's 8,160. Okay, this is what it is, and this thing is gonna be okay. So let me just do this. I was trying to see if I can do it in some other way, but no, I think I need to use this all full power sense. This is my fault for getting into trouble not doing it later. Okay, but what I will have over here is so we'll have a 4 and then 38 and then a 0. Okay, so that's what I will have over here. And if I do my math right, which I doubt, this guy is going to be a 4 and then an 8 and then a 2-0. Okay, so hopefully I'm right because, I'm just doing it out of the top of my head because I want to do it that way. So if I'm wrong, you will tell me. I'm a pro, buddy. What can I tell you? I'm a freaking pro. Now, this is the important thing. The numerical values, they are not so relevant, but let's just do it. This thing is positive, okay? So this thing should gave me a positive. Now, what I'm trying to do over here is to locate it. Well, just put it over there, okay? Okay, so I'm gonna put it over there. This is 4 or 8, 20. Fine, and then what? Well, what I would do over here is to, how can I join these 2 points? Okay, so how can I join these 2 points? Hopefully you see that these 2 points are joined according to this information. This is a curve, okay? And this is not a straight line because this guy wins. This is squared, x squared wins. So this thing should be a parabola. So this is actually a parabola. And if you see this sign, so this is a concave down parabola, okay? That is this. It's doing something like that, okay? Because it's going as negative. Well, this is just from high school, but you need to take that into account. This is just geometry, but it helps you somehow in order to do this. So two, and you will get it. Let's see what happens at section 2, and if I'm right doing these calculations just by brain, okay? So what I will do over here, I don't know why it gives me some space, but not that enough space. I need to figure that out with this OneNote stuff. Okay, so let me just put it like that. Let's just put section 2. Now for section 2, I still have my chunk over there, same stuff. I have this 10, 20 going up. I have this O, the V, the M. Nothing changed so far. But then what I will look for is I have all this chunk again, and then I see this body over here, which is the 900. This thing is still 120. It's the height of this distributed load. This thing is still X. Well, okay. And if you need more information, this thing is from here to there 80 meters. Okay. This at 80 meters from this point A is where this 900 is acting down. Okay, let's just go. Y. So for Y, I will have the 1020 going up. I will have then minus 900 going down. And then I will have this same distributed load going down. It is like this, minus going down 120 times the base, X, okay? So this guy should be bigger. I don't know. What I know is that the length of the beam, it's X. Therefore, I multiply the base times the height, and that will give me the area, which is how resulting forces for distributed loads are calculated. And minus B equals to 0. Therefore, B equals to, I'm going to pass this guy over there. This thing, hopefully you see, is 120. Okay, so this thing is 120. It stays there as positive, so it's 110 minus 120x. Okay, so I have that, yeah, I have that. When you go from x equals to 8 till x equals to 12, let's just compute it at 8. And if I put it at 8, I will get a 960. Okay, so yeah, it's a 960 minus, I will have this, minus this is what I'm dealing with. So if you have this thing right, this should be 8 to 8, it should be 840. Okay, minus 840. Good. Now when I'm at 12, I will get something different. Well, let's just see. It's a 120 minus 12 times this, which is 12. Okay, so it is 120 minus this over there. So if I calculate this right in the right way, this thing will give me something. Okay, let's just see how much you will. It could be a minus, and it will be a 13. Yeah, 1320. Okay, this is what I will have over there. Now let's just go back to the drawing board. Oh my God, it does this thing again. So let me just, it's doing this thing again that it just passing this information again. Well, okay, so let's just try to get it. I'm gonna need it later. Okay, so I'm here at 60, but then something pushes me down till minus 840, okay? This is what I have at 8, V equals to 8 for this section 2. And then something happens. What happens? Well, let's just see this. Okay, let's just see. Let's just put it over there, and let's just see that this equation. It's a, well, I don't know what is happening over there, but this equation is actually a straight line with a negative. Okay, this guy is actually a negative. Therefore, what you will get over there is a straight line with a negative slope. Okay, so this thing is like this, and it will get me down to minus 1320. Okay, this is what I will have over here. Okay, I don't know if you remember, but we have a roller over there at C, and this guy actually pushes me up. It actually pushes me up till I got a 0 over there. So this thing is actually putting me in equilibrium. All these things is actually getting me in equilibrium, okay? So this is a good thing to have. Let me just put it over there. Now, everything that I have put over there just went off. Thank you for that one. So I don't know if you remember, let's just put the results, 1 minus 40, and this guy is minus 1320. Okay, so it was a negative slope over there. This 900 came and pushes me down, and then comes a roller and pushes me up till 0. So this thing is correct. Okay, so you want to know what happened over here, that it just erased itself. It was 120x positive, because minus, and then this was a plus 120, and you need to calculate it this when this guy was 8 and this guy was 12. Okay, so let me just put the values. When this guy was 8, it was a minus 140, and when this guy was 12, it was minus 1320. Okay, so it all comes to 0 here for the shear force. Okay, those are really, really good news. It seems that I'm doing my arithmetics right. Now, let me just put it this way around, and let's just do for the moment. Now, moment regarding O, it should be equal to 0. Let's just start easy, M. Okay, that's the easy part. Let's just put another easy stuff. The 1020 times the X. That's one, it's pretty easy. Minus, it's gonna be a minus. Now let's just deal with the 900, which is easy peasy. So 900 times the distance. I don't know if you see it, but I need to walk all this way, X, and then go back a little bit. This little bit is 8. So it's X minus 8. Okay, so I can go all left, and then I go to the right, but just 8 feet. Right, so this is the actual walking that I did over there, and if you see it, this thing should be plus. And then it comes the distributed load. Well, the distributed load is not that hard. This one is the force. Okay, so this is the force again. This is the force. How do you know? Well, I just did height times base, and that gives me the area. Now, times a distance. So where do you think this chunk of the distributed load is going to locate its resulting force? Well, buddy, right in the middle. Okay, so right in the middle. So you will put X divided by 2. Good. Now, is this thing positive or negative? This thing is going to be a big freaking positive. Now, this thing is equals to 0. You need to compute this again when this is from x equals to 8 till x equals to 12. I don't know why the cursor changes so much. I don't know. I will never know, maybe. Now, I'm just trying to place all those guys over there. So m equals to plus 1020x, this minus 900, x minus 8. Good. And what about it? Well, this is a, 2 just goes out. It's a minus 60x squared, okay? Now you need to compute it when this thing is from 8 and when this thing is 12. Okay, so this is the last part. Now let's see what happens. Okay, so if you put 8 over here, well, if you put 8 over here, this guy just goes fine. That's an easy one. So I think I can take back what I got over here, okay? I think I can take back. That is a 1020 times 8, okay? Minus 60 times 8 times 8 equals to 64. So I think I have the same thing that I got over here. So hopefully I'm doing the same mistake all over again. So this is 4,820. Good. So this will give me to the same place. This will get me to the same place. So I am actually beginning my section 2 where I end my section 1. Okay, good. Now let's go about computed at 12. So computed at 12, this thing will be something different. So this is 1020 times 12. Oh my God, I'm gonna make myself a mess with this stuff. So minus, I think I can put this guy already because 12 minus 8 is 4. So 4 times 9 is 36. So I have a minus a 3,600. And now I have a minus 60 times 144. Okay, so hopefully I can do this something with this. Okay, so this is 10, 20, and this is a 12. Now this is a 12. I'm looking for a 0. That's what I'm doing over here. I'm looking for a freaking 0. So I can actually get it. Now minus 60, 12, 12, okay? So if this thing is actually 0, hopefully, I don't know, this guy will just need to go, okay? So what I will have over here, I think I got it. Look, I just have as a common factor the 12. So the 12 is gonna multiply the 1020 minus the 300 minus the 60 times the 12, okay? So no biggie over here. I'm just putting as a common factor the 12. And if inside of this parenthesis it's 0, then I got it. This thing is a 0. This is what I'm assuming that it's going to be 0, but let's just check it. So this is 12, and this minus this one will give me to a 720. Okay, this is what I did. Minus this, guys, is 720. So, whoops. Pure luck, guys. It was just pure luck. Therefore, this thing is equals to 0. So what you will have over here is you need to get to 0 here. Okay, but how? How can you join these 2 points? Well, just put something over there. Well, let's just not do that. Let's just see about the equation. So this horrible equation over here is actually, you will say, well, a straight line. Well, no. Hey, a straight line. Well, no. This is actually a parabola. So the biggest order of this equation is the one who wins. So it says it is a parabola with a minus, okay? So it's a concave down parabola. So let's just put again the concave down parabola. Oops. So it's doing, oh my God, it's doing this stuff. Yeah, I was pretty sure that at some point it will do its stuff. Okay, so right here, I'm gonna put it over here. There you go, beautiful. It got beautiful over there. Well, I didn't think it was gonna be that well. I mean, in terms of getting this thing numerically, but it just went well. Okay, so this is the thing. This is how you draw these diagrams for distributed loads. The big guy, the most difficult guy, I will say, is a triangular distributed load. So we will deal with that later. Okay, so see you guys. Stay safe.